Hey guys, my name is Sergey, and today I'm gonna be talking to you about another design pattern. And to be more specific, we're gonna be talking about creational design patterns, in particular the abstract factory method design pattern, which is, by the way, pretty similar to factory method design pattern. With an exception that it is a little bit more, complicated, maybe, but not too much. They are pretty much similar, at least in my opinion. And yeah, I found this picture on the internet, and basically, speaking. This design abstract factory method design pattern is a creational design pattern which provides an interface for creating families of related or dependent objects without specifying their concrete classes. All right, so what the heck does it mean? You might ask. First of all, we have an abstract product class, right? Which is gonna be seen as an interface for a family of related products like this, right? And by using interface abstract factory classes, all right, abstract classes, we might extend this class, base class, and we might design our concrete factory class, right, in order to create a concrete product object, all right. And but the client, which is shown over here, up here, right, doesn't need to know anything about the implementation of a particular class, product class, right? Because it communicates directly with with factory in order to create a concrete product. So hopefully that makes sense, and as we move along, I'm going to show you how to implement it with a couple of examples. And yeah, it's not very difficult, to be honest, when it comes to practice to implementing this particular design pattern. And I'm gonna use the C++ programming language because as I mentioned in the previous video, all of these design patterns, which are, I believe, 22 of them, they are at the moment, they were created in 90s, if I'm not mistaken, by a group of guys who were concerned about problems with which C++ programmers faced when dealing with object-oriented programming paradigm, in order to make life easier for them to solve common occurring problems which might happen here and there in programming, in your daily life. So, all right, without further ado, let's get started. Let's jump in our terminal. I'm on Linux Ubuntu. You can use whatever operating system you prefer. I'm using the Vim text editor. I like using this text editor because it's lightweight, it's fast, it doesn't have to be installed, it comes pre-installed on Ubuntu, on Linux. But for solving some kinds of problems or maybe algorithms, it's pretty, convenient, I believe, but for programming, for web development, for example, it might not be useful, might not be convenient, I believe, I should say. But anyways, let's I'm gonna comment my code as much as possible so that you guys will be able to refer to it later if you wish, of course. Alright, so we're gonna say implementing abstract factory method design pattern in C++, using object-oriented programming, of course, because otherwise those design patterns are pretty useless. Okay, so here is our strategy, little strategy, and during this video, I'm gonna refer once in a while to this picture, so that you guys will be able to see it more clearly what's going on, in the terminal, in our editor, I should say. So first of all, we should, I believe, define an abstract product class with a pure virtual functions, I believe. And the pure virtual functions are, designed in the C++ programming language to make sure that we use, abstract classes. Okay, that's how abstract classes basically are implemented in C++. In other programming languages, there is, a reserved word such as abstract or ABC in Python, for example. But basically, the implementation, the idea is pretty much the same. Second, next we need to define an actual product class. Which will inherit all the interface, all public interface of the parent class, obviously. And next we should define an abstract factory class, to build a product. Okay, factory class. Basically, these abstract classes are basically their interfaces. Okay, they're like blueprints for other classes which are derived from them. All right, hopefully that makes sense. And finally, we need to define an actual class, right? Class to build a particular object. Okay. So yeah, and let's get started. First of all, we need to include a couple of directives, stream, in order to deal with input-output. Also, we need to include memory, I believe, since we'll work with dynamic memory allocation, pointers, and stuff like that. And don't worry if you are not familiar with dynamic memory allocation, pointers. It's not very complicated topic, and I'm gonna try to do my best to explain everything as we move along. All right, so next we're gonna say abstract class product class. We're gonna gonna say class. So for the sake of this video and for the sake of simplicity as well, I'm gonna use a car example so that you guys will see it more clearly what's going on actually. Car. Alright, let's define public member functions over here. Public. I'm gonna use this public keyword in order to use our to define our member functions, and there will be virtual, for example, car can start. Okay, start car, for example, and it's gonna be equal to 0. Is will be pure virtual function, which will be overridden in a derived class. That's why we marked this function void. It should be void because it doesn't return anything, I believe. Alright, this virtual keyword means that this function will be implemented in a derived class. Okay, and for dynamic polymorphism we should use virtual destructor, so that our objects will be destroyed in a proper order when we are done with our application. Okay, so I'm gonna say like this, virtual destructor, destructor. Can type today, sorry about that, guys. So basically that's it for our abstract class. So let's create a couple of actual classes. Okay, first we'll create for example Ford class, which is gonna be extend from the car class publicly. Yep, I'm gonna say public member functions right here. Public. We'll say void start car override. We need to override the behavior of our interface, basically. All right, and here we just can see out starting Ford, my Ford car, something like that, and line. Okay, and that's it. And let's create one more, Mercedes, for example, since I like German cars, like everybody else, I believe. Public car. I'm gonna say public member functions. My fingers are a little bit fat, that's why it's a little bit difficult for me to type properly. Sorry about that, guys. Start car. We're gonna override this base pure virtual function, okay, which was designed up here. All right, so we're gonna say stdc out starting my Mercedes car. All right, std inline. All right, and next we need to define an abstract factory class to build a product. Okay, abstract factory class. Okay, so and I think that I should center a little bit our terminal so that you guys will see everything what's going on here. Okay, I'm gonna say class car factory, maybe public member functions. And guys, by the way, for the sake of simplicity, I'm gonna keep my classes as slim as possible so that you are not overwhelmed with the amount of include. Stupid me. Sorry about that, guys. So that you are not overwhelmed with all of these classes and complicated functions, including pointer functions and things like that. Dynamic memory allocation. Okay, so I'm gonna say public virtual, because this is an abstract class. Virtual create or make car, I believe. It's going to be equal to 0 since it's a pure virtual function. Alright, which will be implemented in derived class. Alright, so here just as in the previous example, like up here we will use what are we going to use? We will use virtual destructor to invoke dynamic polymorphism. Alright, virtual destructor. And guys, by the way, here and there I might make some typos, little mistakes, so don't be offended by it, since English is not my native language, and I apologize beforehand for making silly little mistakes here and there. Alright, just in case, guys. Okay, yep, I think that should do it. Let's center our terminal a little bit, and yeah, let's create an actual car factory class. A couple of them actually. I'm gonna say class. What did we have here? Up here, Ford. Make Ford class is gonna be extended from this car factory abstract class publicly, of course, since I wanna be able to instantiate this class eventually. We're gonna say we'll say public member functions as usual. Okay. Alright, so public virtual here should be void, of course. No, it's not void. Actually, it should be a pointer to our base car class. Okay, since we're gonna instantiate one of those classes like Ford and Mercedes. Okay, so I will say car pointer. All right, like this. And here actually we'll implement this function. We're gonna say car pointer make car override the behavior of our base class function make car. Alright, we're gonna return new car. Basically we're gonna dynamically allocate memory on the heap for a new object, okay, like this. Alright, new car. So seems like I have a little mistake, guys. Allocating an object, abstract class type. So right, guys, pure natural function. Alright, guys, so I'm trying to figure out what's wrong with my code. Just a second. So what's wrong? Factory, speak forth, blah blah blah, maker, override, return new car object. Return new car, I guess. Method view which one will start the car. Sorry about that, guys. Stupid me. We shouldn't implement, we can't implement, can't instantiate, we should say instantiate this abstract car class, since it's an abstract class, of course. So sorry about that, guys. Just we need to return an actual Mercedes car, alright, or Ford car, I should say. Ford, like this. Ford reliable conversion from returned value type Ford, no function return type car pointer. New, of course. New, like this. Yep. Sorry about that, guys. I haven't been practicing my C++ programming skills for a while, since I'm busy all the time almost with my fucking work. So don't be offended. So alright, and let's write another class. Make Mercedes factory public car factory public return, here we return dynamically allocated memory on a heap for a new Mercedes object. Okay, and yeah, that's basically it. Here we need to scaffold out our main function and main 0. Okay, and here I believe we need to declare a couple of variables, I believe. String, like Mercedes, for example. Like Mercedes, make Ford factory, type. Okay, and we're gonna see out, enter type of car, Mercedes or Ford, for instance. Okay, cdcn type. Okay, and so I need to see. So okay. So I'm gonna check if type is gonna be equal to for the Mercedes, then and here I think I forgot to dynamically allocate memory on the heap for our factory. Okay, so we need to say like car factory, factory type is going to be equal to new, actually going to be no pointer by default. Okay, so if type is equal to Mercedes, then we need to factory type and I think we should transform our input to lower, because a user may type upper letters or lower letters, and it shouldn't matter for us. Okay, and we'll say we'll do it in a for loop, I believe, in an enhanced for loop auto. I'm gonna pass it by reference, since we're gonna we want to be able to modify the original string. All right, type function. See, like this, and yeah, that should do it, I believe. Here we'll say factory type is gonna be equal to new make Mercedes. All right. Else type else if, I should say, else if factory type factory type, so else if stupid me. Sorry guys. Ford, then factory type is gonna be equal to new make Ford dynamic memory location. Here dynamic memory location, here dynamic location on the heap for a new object. Okay, and here we just initialize our pointer to null ptr to get started with. Alright, like this. Factory type seems like I made another stupid typo mistake. Factory type like this. Alright, yep. And next we need to create. All right, we created our factory. After that we need to create actual objects, Mercedes and Ford, for example, depending on what's been passed in here as a string. Okay, no input, I mean. Hopefully that makes sense. And we'll say so create a new car, right, using factory methods. Okay, so we will say car, you know, car is going to be equal to factory type, and we will be able to access the methods of this particular class, such as make car or make Ford or make car, of this make Ford class or make Mercedes classes. Okay, because we define them up here. All right, hopefully it makes sense, guys. So and these methods were they had the return type of the pointer to this car. All right, class. That's why I will be able to use them down here. All right. So, and after that we can say car. start car here. Can use this method. Hopefully. Start car. Alright. So seems like stupid me. Forgot a semicolon. Sorry guys. Yep. And I think that should do it. And after we're done, we should be able to, you know, delete to return memory back to the OS, so as to avoid having memory leaks in our application, alright, which can be dangerous and potentially might crash your program, I guess. Okay. And of course you can use smart pointers in order to be able to automatically return back the memory after objects have been destroyed, but we use just usual pointers, dumb pointers, as they sometimes called, as far as I remember. We'll say delete factory delete factory type, delete what else should we delete? Car, I believe. Okay. Factory type subtract has non-virtual destructor. Factory type car factory. Yep, sorry about that guys, we should mark our destructor here as virtual, since we have to deal with dynamic polymorphism. Alright, and so yep, I think that should do it. We can test out our application. You can say g++-g. We're gonna use a W flag. We wanna see all warnings, and we're gonna use modern C++, which is the version of 23 as far as I remember. Abstract. So what is, just a sec guys. Yep, g++.g, since we want to be able to use debugging mode, alright, of our program. All warnings, std ++23 abstract factory all dash all frog. Alright, seems like we don't have any mistakes, any warnings, which is a good sign. Alright, and we're gonna compile our program using the tool which is called Valgrind. This tool is available on Linux. It's a fantastic tool for, you know, testing your memory leaks and things like that, just for you know, monitoring purposes. Okay, so as to avoid memory leaks in your program. Alright, so So select memory error detector. Yeah, we've got an error, and but we're gonna deal with it a little bit later, right? I'm gonna say Mercedes. Alright. Process terminated. Invalid window size 8. Okay. So here, null pointer. Here else. Forgot to add one more condition, else just gonna see out invalid input. Yes. And then return with -1, which means basically that there was an error in our program. So let's recompile. And run with Valgrind. So port invalid input. Okay. No leaks are possible over here, which is a good sign, but we don't have an expected output, unfortunately. So yeah, I think that let's put this block of code right here. Okay. So that we will port. No. No. So bad, guys. I was wrong. Let's put it back. Right here. So just need to and need to find our little bug. Okay, set this else if type equal fort string type scene type let's the end line here. Let's recompile one more time. Let's run it through Valgrind. Mercedes valid input. So why do I have this error? I'm not sure, but we'll need to find out it as quickly as possible. And type start car, std to lore, and the type gonna be equal to Mercedes. Factor type. Make Mercedes. Alright, guys. Seems like I need some time to debug. Alright, guys. Seems like I found my mistake, and it was pretty obvious. I don't know why I didn't, find it earlier. Sorry about that, guys. After we turned our input into lowercase letters, we should in this if statement we should use lowercase letter as well, and it's pretty obvious. I think that many of you guys noticed it before, and yeah, my bad, guys, excuse me for it, because we comparing lowercase characters with lowercase characters over here, since we turned them into lowercase using this little lower function of C++. Alright, so yeah, I think that should do it. Let's compile our program one more time, and yeah, we don't have any mistakes. Let's run it through Valgrind just to check some memory leaks. Alright, enter type or car, Mercedes or Ford. Let's say Mercedes. Yeah, and we can see starting my Mercedes. So that means, what does it mean? That means that we successfully created a Mercedes car object from this. So let me show. From this class Mercedes class, but not directly, and actually we created it through this factory class, okay, for these member functions, okay, indirectly kind of. And that's the beauty of this creation of abstract factory pattern. Alright, and so let's check it with another car, with the Ford car. So I'll type Ford. Yep, and we can see that this method has been implemented successfully, and not only that, but here on this line we can see that no memory leaks are possible. All heap blocks were freed because we manually allocated. So let me show you. Not only did we manually allocate memory on the heap, but after we were done, after our objects were have been destroyed, okay, they went out of scope, we manually returned memory allocated on the heap, which is the local memory. Alright, there is stack, heap, text, BSS, things like that, but that's not the point of this video, of course. We successfully deleted these pointers, and we kind of cleaned up our memory, and we avoided some possible memory leaks in our application. And yeah, basically, guys, that's it. Hopefully it wasn't too confusing. I believe I know that it might be a little bit complicated, because in order to master these programming techniques, design patterns, and things like that, I think that first of all, we as programmers, as learners, all right, because nobody's perfect. Obviously, everybody makes mistakes during whether it's programming field or maybe in any other field, and even me myself, I I've been programming for several years, but after making a break, having a break, it kind of seems like you start over again. And yeah, but that's not bad. I think that generally speaking, you should have a pretty good understanding in your head. You should be able to visualize these patterns, because first of all, they in the first place, they are created to to make your life easier, to kind of assist you on your achieving your proficiency on achieving your results. I mean, to improve your code, improve your design architecture, and yeah, those patterns, they could be applied to many programming, to solving many programming problems, I believe. And then, yeah, guys, that's it. And I appreciate for your precious time. I know that many of you are busy, and I wish everybody the best. I hope that we and first of all, I know that we are living at the moment in a crazy world with wars and stuff like that. Every bad things are happening right now, and hopefully everything will be okay in the future. The main thing is this: you should take care of yourself, your family, be with your loved ones, love each other, take care of each other, look after each other, and yeah, peace out. All right, all the best, and take care, guys. Bye bye.